Good evening friends, I hope you are following the thermodynamic lectures. Now we are in the different process. The first process is here isobaric process. What does that mean by isobaric process? The isobaric process is nothing but where the pressure is constant. So in this process pressure must be constant. So when the pressure must be constant, which law will be holds the good? So in this process, so which law will holds good? So Charles law will holds good. Charles law holds good. So what is the Charles law? Will saying that the volume of the gas is directly proportional to its absolute temperature. This is the law of Charles law. So then what is the equation of the state of the thermodynamic state equation is nothing but V is directly proportional to T. So the thermodynamic state equation is equal to V is directly proportional to T. Then V is directly proportional to T is equal to V is equal to some constant into T, then V1 V by T is equal to some constant. So now as we are using the ideal gas, the gas will obey the ideal gas equation, then PV is equal to nRT formula we are taking. From this equation V by T is equal to nR divided by P. Just I send this T this side, I send P this side, then V by T is equal to nR by P, then V by T is equal to nR by P. This is the formula we are having. So that constant value is equal to nR by P. Here n is the number of moles of the gas, R is the ideal gas constant, P is equal to pressure of the gas. Now let me go to the different graphs in this isobaric process. Now let me take the different graphs in isobaric process. Now let me take the first graph, PV graph I am taking. So the first graph I am taking P versus V graph. So as we know that in this isobaric process pressure is constant, even we are increasing the volume, the pressure must be maintained at constant. Let me take the initial volume of the gas is equal to Vi, the final volume of the gas is equal to Vf, then the gas at any volume the pressure is maintained at constant pressure because of it is a isobaric process, the pressure is equal to P. Now this is the pressure, this is the pressure in y axis, this is the volume in x axis. This is the PV graph. Now take the second graph, VT graph I am taking, V and T graph, VT graph. So VT graph if we take means now I am drawing the VT graph. So as we know that this isobaric process will obey the Charles law, then we derived that V by T is equal to some constant, or V is equal to some constant into T, there V is directly proportional to T. Now let me take this formula, that constant also we derived, that is equal to nR by P, this constant is equal to nR by P into T. Now I am comparing this equation y is equal to mx, then if we take the volume in y axis V, that is equal to this constant is equal to some m. So this T is equal to an x axis I am taking, let me take this x axis is equal to T, the y is equal to mx, there is no 0, here is the C value is equal to 0. Now what we will get, this is a straight line graph, as C is equal to 0, the straight line must be passes through the origin like this graph will have it. So this graph is equal to V is directly proportional to T. Now volume I am taking, this is the volume on y axis, then x axis is equal to temperature I am taking x axis. What is the slope of this graph? The slope is equal to the slope is equal to dy by dx we take. So here is the dy is equal to dv by, here is the x component is equal to dt. What is the dy by dt? This is the slope we are getting. Then this value is equal to v by t. What is that value? So dv by t value is equal to v by t is equal to some constant, that constant is equal to nr by t. So nr by p. Once again I am writing the slope value is equal to nr by p. This is the constant slope we are having, that is also positive slope we are getting. If you draw a volume and temperature graph. Let me go to the another graph, the third graph I am taking P and T graph. P and T graph I am drawing. So as we know that temperature I am taking an x axis, temperature on x axis, the pressure in y axis, so y I am taking temperature in x axis. So as we know that this process is the isobaric process. Isobaric process means a temperature pressure must be maintained at constant pressure. So if we take the initial temperature is equal to Ti, the final temperature is equal to Tf, but in this process the pressure must be maintained at constant value. This is the constant pressure, this is the pressure is equal to constant. So this is the value. These are about the, what about the slope here? Let me take here the slope is equal to, the slope value is equal to change in y component value into change in x component value. Change in y component in this value is equal to dp, change in x component is equal to dt, then that value is equal to 0 because by dt that is equal to 0, the slope is equal to 0. In the similar manner come to this equation also, this graph also. What is the slope here? The slope, this value is equal to change in y component divided by change in x component, that is equal to change in dp by change in v, that is equal to 0 by dv, that is equal to slope value is equal to 0. Are you getting, I hope? Now let me go to the, what is the work done in the isobaric process. So work done in isobaric process, So what is the work done in isobaric process means, let me take as P is equal to constant, this constant in this process. The isobaric process is nothing but pressure is a constant process. Then work done formula what we are having, the work done is equal to, we are having integral of P dV, this formula we are having. So that means the pressure is constant, this term will taken out, that is equal to pressure is equal to taken out. Then if we are starting with initial volume is equal to Vi, final volume is equal to Vf into dV, then that is equal to PV into, here nothing is there means integral of dx is equal to, nothing is there, integral of 1 into dx, that is equal to integral of x power 0 into dx, that is equal to x power 0 plus 1 divided by 0 plus 1, you will get with limits. Then in nothing is there, so we are integrating some variable parameter, that variable parameter will be appear, that is equal to x will appear. So in the similar manner here v, nothing is there, here 1 is there, we are integrating this one with the variable of v, then we will get v. So the initial volume of Vi, final volume of Vf, that is equal to P into Vf minus Vi. So this is the work done in isobaric process. Now let me go to the, what is the variation of this, what happened about the first law of thermodynamics. So what happened about the first law of thermodynamics? So first law of thermodynamics in isobaric process. So let me write the first law of thermodynamics. What is the first law of thermodynamics? The amount of heat supplied to the system is equal to, it is the change in internal energy plus external work done TW. So we are recalling our formula once again. So as the pressure is constant, it have the possibility it can increase the temperature and it can decrease the temperature. Temperature is not a constant term. Then we will use the formula, the work done formula only we can vary, that is equal to dq is equal to, once again I am repeating each and everything. Dq is equal to, we are recalling the formulas, dq is equal to ncp into dt formula we know, and also dq is du formula I am writing, du is equal to ncv dt at constant volume formula I am writing if we are substituting. So then this formula can be written, first time I am writing this complete formula, so after that I will modify this one. So dq is equal to du plus pdv this formula, that is equal to du plus p into v final minus v initial, this formula can be written. Then can I write this formula like this? We have the formulas for the dq is equal to at constant pressure is equal to dq ncp dt formula is there. In the similar manner, dq is equal to ncv delta t is there, and dw is equal to pdv formula also is there, p into dv formula also is there. This formula can be used if they are provided. If they are provided, then we can substitute in this equation, and also we can use this first law of thermodynamics, how it is modified. This is the final formula and this is the conditional formula. If they are provided, we can use in this above equation. I hope this is about the complete information about the isobaric process. I hope these videos are useful for your preparation. If you are feeling that these videos are useful for your preparation, then I am requesting you please subscribe and also share these videos to your friends. Thank you.